In this video, we will discuss the trigonometric ratios of any angle. So we will explore the formulae y sine of minus theta equals minus sine theta, y sine 90 minus theta is cos theta, and all other formulae that you see on the screen. So let's get started without wasting much time. Let's start with minus theta formulae. So I have drawn a unit circle. By unit circle, I mean a circle with radius 1 unit. And in that circle, we have drawn two congruent triangles, OAB and OBC, where angle AOB is theta and angle BOC in clockwise direction, negative theta. We can label OB as X, AB as Y, and BC as negative Y, because it is in the fourth quadrant, and in fourth quadrant, Y value is negative. And the radius of the circle is 1. So OA is 1 and OC is also 1. Now, if we find sine theta in triangle AOB, we will get sine theta equals opposite side, which is Y, over hypotenuse, which is 1. So that means sine theta is equal to Y. Similarly, cos theta will be equal to adjacent side over hypotenuse. So it is X over 1 or X. Now, in triangle BOC, sine of minus theta will be equal to minus Y, and cos of minus theta will be equal to X. So what do we observe here? Yes, you're right. We observe that Y is same as sine theta from the first equation that we got. That means if we replace Y with sine theta, we will get sine of minus theta equals minus of sine theta, but cos of minus theta is same as X, so that is cos theta. So from here, we can conclude that sine of minus theta is same as minus sine theta, cos of minus theta is cos theta, and tan of minus theta is equal to minus tan theta. Now let's prove 90 minus theta formula. So I have drawn a unit circle, and in the unit circle, I have drawn a triangle AOB, where angle AOB is equal to theta. And I've drawn a triangle POQ in such a way that angle POQ is also theta. That being said, angle POR will be equal to 90 degrees minus theta. So in triangle POR angle is 90 minus theta. Now in triangle AOB, we know that point A can be given as cos theta, comma, sine theta. Do you know the reason why? Yes, you're right. Because cos theta is same as adjacent side, which is OB, divided by the hypotenuse, which is 1 in this case. So OB divided by 1, or I can just write it as OB. And sine theta is same as opposite side divided by hypotenuse, and opposite side in triangle AOB is AB. And the coordinates of point A are given as X coordinate, which is OB, and Y coordinate, which is AB, right? Similarly, in triangle POQ, if we find out the coordinates of point P, we will find them as P as sine theta, comma, cos theta. And that is due to that sine theta here will be equal to opposite side, which is side opposite to angle theta, which is PQ, and cos theta equals adjacent side, which is OQ. And I'm not saying divided by the hypotenuse because hypotenuse is 1, so it will not affect the overall ratio. So you have the point P coordinates as sine theta comma cos theta, and they are equal to PQ and OQ. But here PQ is same as length OR and OQ is same as length PR. And now we can move to triangle POR. And in triangle POR, we know that angle POR is 90 minus theta. And in triangle POR, if you follow the same process to find the coordinates of point P, you will find them as cos 90 minus theta and sine 90 minus theta. That means the coordinates of point P from triangle POQ and coordinates of point P from triangle POR should be equivalent because we are talking about the same point on the circle. And from here, we can conclude that cos 90 minus theta is equal to sine theta and sine 90 minus theta is equal to cos theta. In the similar manner, we can prove 90 plus theta, 180 minus theta, 180 plus theta, 270 minus plus theta, and 360 plus minus theta formulae. And let me give you another way of proving these formulae. Here, I'm talking about using complex numbers to prove these formulae. We know that e to the power I theta is same as cos theta plus iota sine theta. So I can write e to the power I or iota pi over 2 plus minus theta equals cos pi over 2 plus minus theta plus iota sine pi over 2 plus minus theta. And the left hand side can also be written as e to the power I pi over 2 e to the power plus minus I theta. And we can keep the right hand side the same. So cos pi over 2 plus minus theta plus I sine pi over 2 plus minus theta. On the left side, e to the power pi over 2 is nothing but same as iota. And now you might be thinking, how? So let me explain this. E to the power I pi over 2 is nothing but same as cos pi over 2 plus iota sine pi over 2. And we know that cos pi over 2 is 0. So plus I sine pi over 2 is 1. So that is equal to I. That being said, the left hand side now is I times e to the power plus minus I theta equals cos pi over 2 plus minus theta plus I sine pi over 2 plus minus theta. Now the left hand side can further be written as I times cos theta plus minus iota sine theta. And this is again by using the formula that e to the power I theta is same as cos theta plus I sin theta, and similarly e to the power minus I theta will be equal to cos of minus theta, which is basically cos theta, plus iota times sine of minus theta, which is minus sine theta. And that is why I'm using a plus minus sign here. So iota times cos theta plus minus iota sine theta is equal to cos 90 plus minus theta plus iota times sine 90 plus minus theta. And on the left hand side, we can multiply by iota inside the bracket. So we'll get iota cos theta plus minus iota square sine theta equals, the right hand side remains the same. So cos pi over 2 plus minus theta plus I sine pi over 2 plus minus theta. On the left hand side, we can change iota square as minus 1 because we know the value of iota square is minus 1. So the left hand side now will change to I cos theta minus plus sine theta equals cos pi over 2 plus minus theta plus I sine pi over 2 plus minus theta. And now we can compare the real parts and imaginary parts on both sides. So we can compare the real part on left hand side, which is plus minus sine theta, with the real part on the right hand side, which is cos pi over 2 plus minus theta, and then you can compare the imaginary terms as well. So comparing the real parts, we get cos 90 plus minus theta is same as minus plus sine theta, and sine pi over 2 plus minus theta is same as cos theta. So from here, you got the formula of cos 90 plus theta is minus sine theta, cos 90 minus theta is plus sine theta, sine 90 plus theta is cos theta, and sine 90 minus theta is also cos theta. The same method can be used to get the formula for 180 plus minus theta, 270 plus minus theta, 360 plus minus theta. At this point, you might be dumbstruck and feeling like, how can I remember all these formulae and use them in exam when needed? So let me give you a few simple steps in which you can remember all these formulae very easily. And these rules are, whenever you are at 90 plus minus theta or 270 plus minus theta, you will use the co-function of the given function. When I say co-function, that means for sine, the co-function is cos. For tan, the co-function is cot. For secant, the co-function is cosecant, and vice versa. So whenever you are at 90, 270, or any odd multiple of 90, I'll say again, any odd multiple of 90, we will change the function to its co-function. And whenever you are at 180, 360, or any multiple of pi, we will use the same function. Now, this was about changing the function to its co-function or keeping the same function. Rule number 2 is to check in what quadrant the terminal side lies. So if the terminal side lies in the first quadrant, you will choose positive sign for your answer. If the terminal side lies in the second quadrant, you will choose the answer as positive if it is sine or cosec. And in the third quadrant, it will be tan or its reciprocal, which is cot. And in the fourth quadrant, it is cos or its reciprocal, which should be positive, and all other answers should be negative. Now let's look at some examples and try to apply this information. So let's find sine of 2000 degrees. If we divide 2000 by 180 degrees, we will get 11 as the quotient and 20 as the remainder. So sine 2000 can be written as sine 11 times 180 degrees plus 20 degrees. So here we have something as n pi plus theta. And we know that whenever you have a TRIGO function of n pi plus minus theta, we keep the same function of that angle theta. So this can be written as sine 20 degrees. And now we will decide the positive or negative sign. For positive or negative sign, we need to see in what quadrant the terminal side lies. In what quadrant the terminal side lies. So we have 11 times 180 degrees. So 11 times 180 degrees means starting from positive x-axis, you go 1 time, this is 2 times, 3 times, 4 times. And if you go this way, you will find out that it is what? It is 5 complete circles and 1 half circle. So 5 complete 360-degree cycles and 1 half cycle. 1 half cycle will land you where? It will land you in the second quadrant plus 20 degrees. That means you are in which quadrant? You are in third quadrant. And in third quadrant, by using after school to cinema, in third quadrant, only tan is positive. That means here we will use a negative sign. Let's look at another example. Let's find out tan 19 pi over 3. So here you are given the angle in terms of pi. You can solve it in terms of pi, or you can convert it in terms of degrees and then solve it. Here I will keep it in terms of radians. So you have 19 pi over 3. Whenever you are given with such situations, what we do is we divide the numerator, the given number, by the denominator, whatever number it is. So I divide 19 by 3, we'll get 6 as quotient and 1 as the remainder. That means we can write tan 19 pi over 3 as tan 6 pi plus remainder, which is 1. So 1 pi, or I can just write pi, over 3. And this is because we know that a mixed fraction can be written as quotient plus remainder over the divisor. Now tan 6 pi plus pi over 3. What we had discussed earlier, that whenever you are at any multiple of pi plus or minus theta, we will keep the same function. So tan will remain tan of angle theta. So pi over 3. Now we need to decide a positive or negative sign. So 6 pi means 6 half cycles. 6 half cycles is nothing but same as 3 full cycles, right? So 3 complete cycles. After completing the third cycle, you are going plus pi over 3. So you are going in, yes, you're right, you are going in first quadrant. And in first quadrant, all trigonometric ratios are positive. So we will use a positive sign. Now let's look at another example, cos 1415 degrees. So here, if I divide 1415 degrees by 180 degrees, I will get 7 as the quotient, and the remainder is 155. But here, one thing that we should remember is whenever you are applying these sine 90 plus theta, cos 90 plus theta, sine 180 plus theta, sine 180 minus theta formulae, theta always lies between 0 to 90 degrees. It has to be an acute angle. But in this case, you are getting it as an obtuse angle, more than 90 degrees. So what should we do in this case? One thing that you can do is instead of dividing by 180 degrees, you can divide by 90 degrees and use that approach. The second thing that I suggest is whatever remainder you got, you subtract it from 180 degrees. So you'll get 25. So your theta will be 25 and increase the quotient by 1. And why I'm saying this? Because if you do 1415 degrees as 8 times 180 degrees and you subtract 25 from it, you will get 1415. That means we can write cos 1415 degrees is equal to cos 8 times 180 degrees minus 25 degrees. And now what do you have? You have cos of 8 times pi. That means we will use the same function. So cos 25 degrees. And now let's decide the positive or negative sign. So here we are talking about 8 pi, means 8 half cycles. 8 half cycles is same as 4 full cycles of 360 degrees. After 4 complete circles, what we are looking at? We are looking at minus 25. So you will go back by 25 degrees. So after completing full 4 circles, we will go back by 25 degrees. That means we are in fourth quadrant. And in fourth quadrant, we know that by after school to cinema, we are in cinema. That means cos is positive and its reciprocal is positive. So we will use a positive sign here. Let's use the second approach to solve cos 1415 degrees. So here, if I divide 1415 degrees by 90 degrees, you will get 15 as the quotient and 65 as the remainder. So we can write cos 1415 degrees as cos 15 times 90 degrees plus the remainder, which is 65 degrees. Now, here we are talking about an odd number multiplied by 90 degrees plus theta. So we talked about whenever you are at 90 plus minus theta, and specifically odd multiple of 90 degrees. not an even multiple, odd multiple of 90 degrees plus or minus theta, we will change the function to its co-function. So we are given with cos and its co-function is sine function. And if we were given with sine, its co-function is cos. If we were given with tan, then we would change it to cot. And if we were given with cosecant, we will change it to secant. So sine of 65 degrees. And now we need to decide plus or minus. 15 times 90 degrees will be same as 3 complete circles. And then going 390 degrees, which will land you in third quadrant, plus 65. Plus 65 means you are going to the fourth quadrant. And in fourth quadrant, by after school to cinema, we know that cos is positive. So, and the initial function that we were solving is cos. That is why we will use a positive sign. Some people confuse it with the final answer. The final answer that you got is in terms of sine, but the initial function was cos. So we are choosing the sign based on cos, the initial function, and not the final function. So here, some people might think that only cos is positive, but the answer is in terms of sine. So let's use a negative sign. That is wrong. Always remember, we will use the initial given function as the base function. And based on that, we will use plus or minus sign. And now you might be thinking that we solved this question earlier and we got the answer as cos 25. And here we are getting sine 65. Is that wrong? No, this is correct. Why? Because sine 65 is basically same as sine of 90 minus 25. Sine of 90 minus 25 is nothing but cos 25. So in this video, we discussed the trigonometric ratios of any angle and how to easily remember these formulae. In next video, we will discuss the trigonometric ratios of compound angles. So I'll see you in the next one. Bye.